Welcome to the Rich Report, a podcast with news and information on high-performance computing. Today, my guest is from Cisco. We have Jeff Squyres. Jeff, we saw each other at the end of the show and kind of did a wrap-up of SC11. But then I was reading about the demo that you were showing all week, and I thought yes. So, what was this demo?
All right, yeah. Let me tell you a little bit about it. I'm sorry I didn't get to show it to you, but you're right. It's such a crazy week that there's a million things to do, and I can't do all of them. But the demo that I was showing was in the Cisco booth at Supercomputing. Basically, we're showing really, really low latency over Ethernet, and we're doing it with commodity technology. So let me just show you right here. This is I have a little canned demo. It's not very sexy to watch, but it's interesting to watch. In that this is a NetPipe, which is a standard MPI latency and bandwidth benchmark. And I'm just going to run it here. This is with two servers running across Ethernet. Now, the Ethernet is back-to-back, so there's no switch in between here. But what's the interesting part is you look, I'm starting out at 5.19 microsecond half-round trip MPI latency, which is really darn low for Ethernet. Now, obviously, there are some lower ones out there, but the tricky part here is that this is not iWarp, and this is not Mellanox Rocky's product. This is Cisco's NIC, which is actually sending raw Ethernet frames back and forth, and we're doing it from user space. So there's two pieces of technology here that allow us to get down to this 5 micro kind of range, which we think will be fairly attractive to the missing middle types of customers. Number one is a virtualization technology called VFIO, Linux VFIO. Stands for Virtual Function I/O. And what it is a project that it's not fully upstream yet. It's still cooking, so we kind of took a snapshot of it and made a demo out of it here. But the goal of the VFIO project is to expose PCI devices to user space. So you can take an Ethernet NIC, for example, and expose a send queue, receive queue, and completion queue up in user space for something like an MPI process to use. And with that, MPI can just send and receive raw L2 Ethernet frames, across the wire. And so there's no TCP processing, no IP processing of any kind, and it's talking directly to the hardware. So this is actually OS bypass. It's a slightly different form of OS bypass than most people are used to thinking about with InfiniBand and so on, but it is OS bypass. Now, the other piece of technology that makes this kind of interesting is the Cisco NIC that we're using here. It's actually an old NIC. It's been on the market for about a year. We've been selling it in the enterprise space for a long time, but we've been using it in virtualization kinds of deployments, because what makes this NIC special is that it advertises itself on the PCI bus 128 times. Actually looks like 128 NICs, even though it's only one physical NIC. Now, if you tie this concept together with the VFIO concepts, what I can do is I can expose up to 128 virtual NICs straight into user space. Now, again, this is virtualization technology. It's usually used in hypervisor bypass kinds of scenarios so that virtual machines can get, raw, bare metal networking kinds of performance. But here we're kind of bastardizing it and using it for HPC or technical computing kind of scenarios. So the way that I'm doing this here is that every MPI process kind of claims its own virtual NIC in user space. And so therefore every MPI process has its own unique L2 MAC address. And so every MPI process can just send frames across the wire to any other destination MAC address, and it goes straight to that process. So, it's the same old Ethernet that you're, familiar with, but it gets routed through the switch just through MAC addresses, not through IP addresses. Now, what this does is, I already said how the send side is operating system bypass, right? We have a send queue, receive queue, and completion queue on the send side. But on the receive side, since every MPI process has a unique MAC address, the hardware on the virtualized NIC itself directly sends the incoming packets straight to the destination MPI process. So there's not even any multiplexing on the receive side in software. The hardware does the whole darn thing. So incoming packets are steered directly to the MPI process, and this gets us down to about this 5.19 microsecond latency, which we think is kind of interesting. And I should point out, too, sorry, you have to forgive me for a little bit of advertising here. This is our first generation virtualized NIC, and like I said, it's about a year, maybe a year and a half old or so. Our second generation NIC is coming out. I don't think I'm allowed to say the exact date yet, but it's coming out fairly soon. And the round trip latency numbers here that we're looking, I'm sorry, the half round trip numbers that we're looking at right here, 5.19. The next generation NIC, the numbers are significantly lower, and we think that's going to be very interesting for customers to see.
So, Jeff, just for our listeners' benefit, what kind of numbers, without using VFIO, would they expect on a card like this? 5.19 with the virtualization applied, the VFIO. What would we get with the bare metal, with the standard way of operating?
Yeah, so with the, a normal TCP-based MPI, depending on the quality of your card and your server and your switch and things like that, you'll see anywhere from 20 to 50 microseconds or so. Good ones will get you down in maybe the 15 to 20 kind of range. Average to crappy ones will get you up in the 50 kind of range.
Okay, so then this card isn't like an exotically priced kind of device, but you were able to map this new technology onto it to get this kind of performance. Is that correct?
Yeah, now the Cisco sales guys, and I admit I don't follow our pricing at all, but they tell me that this is a very commodity 10 gig NIC, and that it's priced very competitively. What exactly that means in terms of dollars, I don't know, but they all tell me that it's quite competitive with other 10 gig NICs out there.
So, just looking forward and this new device comes out, would this be a different way of writing MPI code with this VFIO as part of your scheme? Or how would it implement?
So actually, we were given. So all right, let me give a little background here. We've been selling this NIC for over a year, as I've said. We finally actually got permission to dual use this NIC about 2 weeks before supercomputing. So we've been lobbying internally in Cisco to say, hey, this virtualization NIC, we think we could do some cool things with it in the HPC space. And we finally got permission about 2 weeks before supercomputing. So literally 1 week before supercomputing, I started to write the MPI demo for it, which means I took, in this case, it was OpenMPI, and I wrote a new transport plugin for OpenMPI. It took me 1 week to get a demo quality BTL transport module going on here. It was actually relatively simple to do. It's about 3,000 lines of code or so. And when I'm done, I got to add, a bunch more error correction and things like that. But in comparison, something like a verbs transport layer is more like 18,000 lines of code. So it's a tremendously simpler model than compared to some other kinds of transports. TCP, for example, is about 4,000 lines of code. Now, what I think you might have really been asking me was, does it affect MPI codes at all? And the answer is no. You run your same old MPI codes, and it just has a different transport underneath, and it should still run exactly the same way it did, just with nice low latency like that.
Well, this is very cool, Jeff. We tend to think of virtualization as something that slows things down, and this is just the opposite. So it's kind of an eye opener.
Yeah, it's kind of fun that it's virtualization driving HPC instead of the other way around. So this is why we were kind of excited to bring this to market, and we think that there'll be a lot of people who are interested in this. People, that we so-call the missing middle, that they don't want anything exotic. They just want a 4, 8, maybe 16 node cluster that they just want to run some ISV app on, and they want it to, somebody push the go fast button for me and make it work, go. And we think this will be attractive.
That's terrific. And you're doing that with 10 gig Ethernet, something that's kind of I guess that is commodity these days, isn't it?
It sure is. It's landed on motherboard, so by definition it must be a commodity, right?
Okay. Well, very cool, Jeff. Well, thanks for sharing that with us today.
Thank you. Appreciate your time, Rich.
Okay, folks, that's it for the Rich Report. Stay tuned for more news and information on high-performance computing.